C++ allows us to use the power of templates, just as we saw used in the standard vector when we build our own classes and our own functions. Let's see how this works. A templated variable is declared by using a special syntax before the beginning of a class or the beginning of a function. Looking at the beginning of a class here, before the definition of the class, we have template with an open angled bracket and type name t. The only thing that's going to differ in this syntax is the t. This is the variable name for our template. So here in template type name t, we see that in our class list, we can have things with the type t. When we initiate this list class, we can have a list of integers or a list of strings or a list of UIUC cubes. It can be anything because the templated type can take on another type when the data structure is initialized. Likewise, we can also have templated functions. Here we see the exact same syntax, template type name t, and inside the function itself, we can use t as a type. Here is ta and tb. And this function, this int max, simply looks at a and b, compares them, and returns the largest one. It returns the maximum of those two variables. Let's see how this actually gets instantiated when we run this code and compile this code. Templated variables are actually checked at compile time, which allows for errors to be caught before we even run our program. Consider our max function, which we saw earlier. And when we run this max function, we might call max of 4 and 7. When we call max of 4 and 7, we're asking the program to find the maximum of 4 and 7. Because these variables are both integers, it's going to instantiate a templated version of the max function with integers. So it's going to be read as an int a and an int b are both being compared from the max function. Since we have the if statement that compares whether or not a is greater than b, we're going to check if the integer 4 is greater than integer 7. Since it's not, we're going to go ahead and return b. On the other side of the world, we can think about UIUC cubes. So instead of having a primitive type, we have a user-defined type. And in this user-defined type, we're now comparing two cubes. When we compare a greater than b, we're comparing whether or not the cube of length 3 is greater than the cube of length 6. And this throws an error because we have not programmed the ability for us to find out if one cube is greater than another cube. We haven't overloaded that operator. We haven't defined how a greater than sign might work. And because of that, we cannot compare two cubes. And when we try and compile this code, we're going to find that there's going to be an error. Let's actually see this as an example. Looking at the main program for the CPP templates video, we have our max function that you saw earlier at the very top of our program. And inside main, we're going to call the max function several different times. On line 22, we compare max of 3 and 5. We expect this to output the number 5. Then we compare the max of a and d. Notice the first was a comparison of integers. The second one's a comparison of characters. Between a and d, d is the largest. Next thing is we're going to compare the max of hello and world. This is a comparison of two strings. World is the larger string, so we expect world to be outputted. And then finally, the last line is we're going to compare two cubes. We're going to find the max of cube 3 and the max of cube 6. We argued there is no idea of how to do a greater than operation between two cubes, so we expect this code to not compile. When we remove this one line of code, when we remove line 25, we're going to see that this code should compile and print out 5D and world. Let's go over to the console and see if this works out. Here at the console, moving into this CPP templates directory, I'm going to run make, and we get an error. So we see invalid operand for binary expression UIUC cube to UIUC cube. And this is the a is greater than b. So for a is greater than b, we don't know how to do that for UIUC cube, and we can in fact see where this is specifically called in the next error message. Note an instantiation of function template specified max UIUC cube requested here. So when we did the max of the two cubes, we weren't able to create the templated type because we can't compare a being greater than b. Let's go ahead and edit this code and remove this line 25 so that we can see the rest of this code work. Editing main.cpp. commenting out line 25, saving the file, exiting, running make, and now running /main, since main ended up compiling this successfully. And we see the max of 3 and 5 is indeed 5, the max of A and D is D, and the max of hello world is world. So now you've seen how we can create a templated type inside of our own code. And we're going to make use of this as we build more and more complicated data structures. Before then, we want to talk a little bit more about the C++ language. So I'll see you next time when we talk about inheritance. I'll see you then.